Hey there, Calc kids. Things got a little bit crazy when you weren't around, so I will have to take care of this. Okay. Today we are looking at 4.1. We're going to be looking at extreme values of functions. Absolute, local, like your relatives. Finding extreme value and why. Find the max and min values is going to be important in real world. Like if you're in business, maximize profits, minimize costs. If you're an engineer, minimize cost, minimize amount of material use, maximize your tensile strength, okay, all that good stuff. For cooks, maximize tastiness, minimize amount of fats in it. Okay, I don't know, I'm just making up stuff. Okay. Absolute extreme values. What this says is something is an absolute maximum on your domain if that value is greater than any other thing you can plug in. Okay, it's the top, it's the king dog, it's the highest number you can get, it's your maximum profit, you cannot go above it. Okay. Your absolute minimum, ditto, but less than. Okay, in your domain. In your domain. Okay, so go ahead and write that. I know what you're going to say. This is ridiculous. This doesn't make any sense. Why are you making us write it? But just trust me, you need to know. Okay. So again, if you are on a closed interval, and you're continuous between it, then if you're looking for a max and min, okay, you will have a max and min. It's guaranteed that you will have a max and min if it's on a closed interval, okay? Because if you don't find your, like right here's a max, here's your min, right? Sometimes it could be your endpoints, like here's your max and here's your min. So when we get to testing for max and mins, you have to test your endpoints and your critical points. And you're probably thinking, what's a critical point? I don't know. Max, min, min, max. Okay, so we're going to have to test our critical points and our endpoints. If you haven't figured out, our critical points are going to be where our derivative equals 0, because that gives us our horizontal tangents. Yeah? Yeah. Again, quick run through. Absolute min, it's the smallest value. Local max is the greatest one nearby. Okay, you increase and decrease. Local min, smallest one nearby. Write this. Very, very, very noteworthy stuff. Whoa. Local min and max, not going to be right. Just understand that they don't have to be the absolute. You guys are going to have to be smart when you look at this stuff. Let's just do a problem. Okay. A function has a local max or local min in this domain if your derivative equals 0. That is a critical point. So find the derivative, set it equals 0 to find your maxes and mins. You'll still have to plug in your endpoints. It's a lot of talking, no problems. Okay, take the derivative. The point at which your derivative equals 0, or where it does not exist, is called a critical point. Because that's going to be where your function is deciding if it's going to be a max or a min, or if it's going to be discontinuous, discontinuous, disingenuous. Well, anyway, let's take a look at an example. find the absolute max and min for your function f of x is 3x to the 2/3 on the interval -1 to 2. Okay. So, first things first, I have to find my derivative of the function. Okay, so I move my 2/3 out in front. And 2/3 minus 1 is -1/3. Okay. 3's cancel, right? So you're left with 2x to -1/3. Which is the same thing as 2 to the x over 1/3, because that negative. Which is the same thing as 2 over cube root of x. Okay, so that's my derivative. Now, what I need to do is ask myself, what are my critical points here? Well, does this ever equal 0? I'm supposed to ask by cube root of times by cube root of x. And it goes away. And you get 2 equals 0, which doesn't work. Okay? So it never equals 0. But is there a spot where this is not defined? Well, can you divide by 0? No. So at 0, when x equals 0, we're undefined. Right? Not to be confused with hard defined, we're undefined. Well, anyway. So at x equals 0 is a critical point. Okay? So what we do is we have to kind of make a chart. I don't really make a chart. I kind of make almost like a test plotter dealio. We need to test our endpoints and our critical points. Okay? Our endpoints are -1 and 2. And I got that from up here. Okay? My critical point is 0. And I got that from over here. Okay? Now what I'm going to do is I'm going to plug those into my original function. Okay? So I get, original function. I get 3 times -1 to the 2/3. Which -1 squared is 1. Cube root of 1 is 1. So I get 3. Okay? So then I plug in 2 to my original function. And I get about 4.76. I use my calculator. Then I plug in 0 to my original function. And it equals 0. So I can conclude that this is my min. And since this is the biggest, this will be my max. If you look at the picture, it kind of looks like this. Okay, so it makes sense that here's my max at 4.76. And here's my min at 0, 0. Okay? You see why we don't have a derivative, or it doesn't exist at 0.0? It's because we have a cusp, right? And at cusp, there is no derivative. Makes sense? One more example. Okay, let's try one more. This one's a little bit tougher. Okay, find the extreme values of this beast. First, I need to find my f prime. First, I'm going to take this one and change it to 9 minus x squared to the -1/2. I can do that because remember, square root is the same as to the 1/2 power, and then the negative can bring it from the denominator to the top. It's frigid in here this morning, afternoon. Okay. So when I take my derivative, I move the -1/2 out in front. 9 minus x squared to the negative 3 halves, because negative 1 half minus 1, times the derivative of my inside, derivative of 9 0, times negative 2x, right? Okay. Negatives cancel, 2's cancel, so I actually get x over 9 minus x squared to the 3 halves. Because again, that negative just brings it down below. Okay? Just like negative people bring mu down, negative powers bring the function down. Okay? And so I set that equal to 0. Right? Well, when will this function equal 0? Remember, if you have something equal 0, you can just look at the top. X equals 0 is a critical point. Okay. What else do we have to do? Well, our original equation's domain is from negative 3 to 3, because we can't take the derivative, we can't take square root of a negative, and we can't divide by 0. So that's our original domain. So down here, you can say, well, when you plug in 3, you get 0 in your denominator, but it's not in there because we couldn't have done it to the original. Okay, so just x equals 0 is a critical point. So we're going to take that and plug it into our original equation. You get 1 over square root of 9, which is 1/3. What's that mean? Is it a max or a min? Well, what you have to do is pick a point on the left and the right side, left side, right side, and see what happens. So let's say x equals negative 1. 1 over square root of 9 minus negative 1 squared, right? Again, we have to plug it into the original equation here, because we are looking at the original equation. What just happened? Anywho, again, we're looking at the original equation. We get 1 over square root of 9 minus 1, which is 1 over square root of 8. Okay. Which is less than 1/3. Okay. For the right side, we do 1 over square root of 9 minus 1 squared, which you see it's the same problem, and we end up with 1 over square root of 8, which is less than 1/3. So 1/3 is our max, and it occurs at x equals 1. I'm sorry, 0. Okay? That's it. This is important. It's going to come up a lot. Enjoy.